For this equation, we're going to need to go through and solve. I see that we do have a radical in the problem. Anytime that you have a square root or a cube root, fourth root, there's a few different ways of doing the problem, but one of them would be for you to isolate that radical all by itself. So I have a radical here, and outside of the radical, I have a plus 8. So a good first step here would be to subtract 8 on both sides. That would give me 4 is equal to the cube root of an x minus 2 squared. Over on the right side now we have our cube root isolated. Again, there's a few ways of doing this, but if we're going to do this with small steps, what we would want to do next is get rid of the cube root. How you get rid of a cube root is by raising both sides to the third power. Over on the left, we have 4 to the third power. 4 to the third power is 64. And on the right, the cube root and the cube, those would just cancel each other out, so we would just get what is inside the radical, which is an x minus 2 in parentheses squared. At this point, you would have a couple of things that you could do as a next step as well. You could do the square root on both sides. If you do that, you're going to need to remember to do the plus or minus, and that's totally fine. If you didn't want to do that, you could take this x minus 2 squared, and you could think of it like an x minus 2 times another x minus 2, and just FOIL this out. It's a little longer this way, but students typically get the problem right when we do it this way. So I'm going to do it this way, even though it's a little bit longer. So I'm going to go through and FOIL out this right side. If I do that, our 4 terms would be an x squared, a minus 2x, another minus 2x, and then a plus 4. So this is the F, O, I, and L of FOIL. And we have a couple terms here in the middle which are like terms, which I'm going to combine together. So on the right side of our equal sign, we have an x squared minus 4x plus 4. I see that I have a quadratic here. I have a few different ways of solving a quadratic. I could try to factor, maybe the quadratic formula. Synthetic and long division would work. If you really wanted to, you could complete the square. So again, you just have to kind of decide what it is that you want to do. I'm going to see if maybe factoring is going to work. That's pretty quick if we can use the shortcut. If we factor or use the quadratic formula, I do need 0 over on one side of the equal sign. So I would subtract 64 on both sides. If I do that, I would have 0 is equal to x squared minus 4x minus 64. Sorry, minus 60. 4 minus 64 is a negative 60. And then from there, we could go through and do the add multiply method. There is nothing in common with those 3 terms. I could use the shortcut if I can find 2 numbers that add to be negative 4 and multiply to be 1 times negative 60, which is negative 60. There are 2 numbers that fit that pattern. They would be a negative 10 and a positive 6. And then from there, we can factor this right side. So we would have 0 is equal to an x minus 10 times an x plus 6. And now I can take and set x minus 10 and x plus 6 each equal to 0. And go through and solve. Oops. Ugh, 2 mistakes, but I've caught both of them, which is good. So with this one, we're adding 10 on both sides. This one, I should have been subtracting 6. So we end up with x is equal to 10, x is equal to a negative 6 as our 2 answers. And then the question is, do we have to plug those back in and check? When you go through and you're solving a problem that has a radical in it, sometimes when you get to the end, you have to plug those numbers back in and check them to make sure that they work. You do that whenever you raise both sides of your equal sign to an even power. So if you look at the steps that we did here, there was one spot where we did raise both sides to a power, but we raised both sides to the third power. And because that's an odd number, we do not need to check our work. It's not a mandatory part of the problem. You certainly could, but you don't have to. But if you raise both of the sides of your equal sign to an even power, part of the problem has to be to plug those numbers back in and check your work. So these two numbers here, we do not need to check. There wasn't anywhere in our work where we raised both sides to an even power, only to an odd power. So our answers are 10 and -6. No need to check our work on this problem.